and I would love to welcome you in front of the whole Joberty team. Welcome to Joberty webinar. For those who maybe don't know us, we are a developers community with a mission to help IT professionals to land their dream job. How are we doing that? By encouraging them to share their experience about IT companies. Currently, we are present in Serbia, Croatia, Romania, Bulgaria, North Macedonia, and officially today also in Slovenia. Actually, we want to grow together with the IT community. And we really think that sharing is caring, and that's why we started a series of free webinars. This is the third time that we are hosting the webinar, and we are very honored to welcome our dear Irina. Irina, welcome.
Hello, hello. Thank you for having me and for this proposal.
Thank you for accepting our invite. Irina is software architect, also Microsoft MVP and international speaker and trainer. I'm sure we will hear some awesome things. And before we start, I only want to add that and to remind you to join our giveaway because you can win 2 tickets for .NET Days. Irina is also a founder of this regional event, and she will tell you something more about it. So Irina, the floor is yours.
Thank you. So first of all, I hope you're seeing my screen.
Yeah.
The tool is saying that you're seeing my screen, but I just want to make sure. Okay, so today tonight actually, we're gonna talk about how gRPC can change the way we're looking at the microservice architecture. And we're gonna see a few ways and a few tweaks and tricks that gRPC brought into .NET as a world. So who am I? First of all, I don't like to talk very much about me, but I'm Irina Scurtu. I'm married and my name is changed now in Irina Dominte, but I'm still, you still find me as Irina Scurtu on LinkedIn and on social media. I'm from Romania. I'm also an independent consultant. I organize .NET Yash user group. So if you want to find that group on Meetup, we are hosting monthly events pretty much and online events. And also I'm a founder of .NET Days Romania conference. Apparently we're a regional conference right now. Check out our website. We have there a lot of awesome speakers, and we maybe meet you in October here in Yash. I teach .NET from time to time. 5 months long classes, and I also blog, but not as often as I would wish for, because I'm also currently writing a book and that is taking all the time from me. So let's see, the monolith, the story. I personally don't want to talk about microservice architectures and fancy things without remembering where we started. So first, when, for example, I was a junior developer 12 years ago, oh my God, the life was very easy for me. I had a big solution. I had everything in one solution file. Everything was there. Everything was self-contained. And my life as a developer was very easy. And depending on how lucky you were, whenever you wanted to build that project and that solution, you could get outside and grab yourself a coffee and relax, because that much resources the monolith consumed. Why was it an easy life? Because whenever you wanted to instantiate an object, that reference was there. You just went there, you just knew this particular object and everything was there. So you didn't need to worry about, I don't know, instrumentation, orchestration, microservices, HTTP call to another service, and so on. Everything was maybe in a clear separation in libraries and so on, but it was very easy. I mean, you just needed to focus on the task at hand, not, oh, what would happen if that microservice was down, or what would happen if this or that, and so on. So that's why I want to remember this. And I would also ask you, who here loves the monoliths or enjoyed working with monoliths? And I will say, hey, I'm here. I would admit, I enjoyed working with this kind of, let's call them architectures. Okay, but as soon the things evolved and things got cheaper, for example, the storage got cheaper and we stored more and more data and so on, we started having architectures like this. We have a front end and the back end, and behind all of these, we had a database. And that specific database was usually Microsoft SQL Service, because if you come from the .NET world, that was the go-to database thingy. We had ASP MVC, we had web forms that basically render everything from the server, but it was self-contained in one block. And a few years along the way, we had front-end apps and we had back-end apps. We had Angular, we had React or whatever JS front-end, and the back-end API that served data to that front-end. A few years back, we started to realize, hey, even with these kind of architectures, when we're talking about scaling the system, well, we could have some benefits. And we started to realize that the future is distributed. And once the future is distributed, we started to also distribute our systems. We started to have more backends to serve a single API. We started to have several databases that talked with those backends. And then those backends talked with different backends and so on. And oh my God, we started to have different topologies. We started to have .NET apps that talk with Go apps, or Node.js apps that need to get data from a .NET app and so on, or even from third-party APIs. And oh my God, things got complicated, because the only thing that we as developers started to do was to simply make HTTP calls. And we started to say, hey, we have REST for everything. We have REST APIs. But one thing with the REST is that one client talks with the server, and between the client and the server, a thing happens. A thing that is called content negotiation. And that content negotiation process happens under the hood. We need to take care of the format of the request, of the payload, to handle errors and retries, to handle authentication, and to handle scenarios where when the model changes, like the model that is sent to the client and the client can't find that specific property, or otherwise, when the server cannot find the specific property that the client sent. There are all kinds of scenarios that we need to cover with client to server communication. But with REST, what's wrong with it? Why do we need gRPC, or why do we need GraphQL or a different technology? Well, one thing that REST does very well is to expose data to the outside world. But in today's particular talk, we're going to talk about what happens inside your system. So we will not talk about, okay, how do we expose this to the outside world? We were going to talk about downstream APIs. So one thing with REST or HTTP APIs, how I like to call them, is that they're very chatty and enforces communication inside the team. Now, it's nothing bad to talk with your colleague or with some other different team. But what happens if you do not know what is the consumer of your API? So then you won't have the ability to talk and say, hey, I'm going to remove a field from the backend. Make sure you remove that specific field from the front-end app and so on. You do not have that luxury. But if we get back to the remote procedure calls, this is a concept that has been around for a while. I don't know, maybe from the 80s or something. You see, there is a tendency of a specific patterns to revive and get back to life from time to time. And the RPC is one of them. So let's look at some code. We have this code. And what happens is that we have an order. Okay, we create an order and we need to interrogate the payment status. And if that payment is processed for that specific order, then we need to arrange shipping for it. Okay, looking at the code, right? Everything seems to be in the same system. But what if I tell you that between these calls, there is a network involved? So the payment status is in one system, and the actual code lives in another system. So between these, there is a network involved. So RPC, as a concept, if you specifically look at it from the code perspective, will make the code look local. Is like call a method. Is that a look and feel in there? And it's prone to errors because us as developers, we tend to use and call methods. And if those methods are somehow obfuscated, right? We don't know that there is a HTTP call behind it. It's prone to errors, right? So an RPC system main goal is to make a distributed system look and behave like a monolith, okay? So making the network communication transparent. You look at the system, you have basically different APIs communicating with each other. But if you look at the code looks like it's part of a monolith. It's like in the same system. So what's the deal with gRPC, basically? So gRPC is a reinvention of RPC. It started in 2001 at Google Stubby. Fast forward a few years, and in 2019, we got it in .NET Core, which is very awesome. And since then, every release of .NET has major improvement for gRPC. So gRPC is contract-based. It's like defining a contract in an interface. You're saying, hey, this is what you need to have and provide. You'll have no code references. You won't have any more add code reference, add package reference, and so on, and use the library. It uses HTTP2 under the hood, which makes it very faster. The serialization is different than JSON, which leads to a smaller payload, and it's available in many languages. And another thing is it does code generation out of the box. So if we look at the client-server architecture that we all know from HTTP calls, now we have something in between these two entities, the client and the server. And when I say here the client may very well be another service or another server. So we introduce this protofile, and this protofile is the interface between the consumer and the server. So let's look a bit at how a protofile works. So first of all, you have the proto syntax that is available on Google. You need to say what is the syntax that you're currently using. You need to say what is the package that you want to generate, basically. And then you would need to say, hey, I'm exposing the service, and that service is called Fibo from Fibonacci. And inside a service, I have a method or an operation that is an RPC operation named compute Fibonacci that has an input and returns, of course, an output, okay? The input and the output are detailed below, because with gRPC, you cannot have like no parameters. You have to have a parameter that has no value. So in our particular case, the inputs and the outputs can be compared with C# classes, are called messages. And these messages have fields and are composed of primary types. So you have the keyword message, you give it a name, and inside it, you will have properties. In our case here, you have a property called number, which has 1 equal 1 and is of type int32. But don't confuse this with assignment, because it's not an assignment. Is simply being binary. It's the order of that specific field inside the type. So if we would have another field, we would have whatever that field equals to, and so on, to make sure that these are numbered and the platform knows how to split the binary string. Okay, so first of all, defining this, you say, hey, this is what I want to expose. This is the data that I'm going to use. gRPC has 4 types, or some people call them modes, of communicating and sending data back and forth. So these 4 methods are unary, which is similar to client-server request response that we all know, server streaming, client streaming, and of course, of a combination of the previous 2 called bidirectional streaming. One thing to note is that every communication, being bidirectional or client or server streaming or unary, it happens inside one request, one traditional request. So there is no other request open to send several pieces of data from the server or from the client. So let's look at this in particular. gRPC unary, it will look like a simple request from the client, response from the server. And if we were to define such a thing in a server's definition, it will look like this, right? We just seen this method. Compute Fibonacci on input and returns an output. Moving along, gRPC server streaming starts with the client initiating a communication with the server getting that communication and sending several pieces of response back. And if we were to define such thing, we simply add for the output the keyword stream. So you get one thing in and several things out as response. And we will see very soon examples of all of these. Client streaming, again, the client initiates the communication, but this time send several pieces of things in, of inputs, and it will get one response back. Similar to the previous example, just by adding the stream keyword, you're saying that, hey, I'm gonna receive several things in, and I'm gonna return one thing out. And bidirectional streaming, it's a combination of the previous 2. So the client again initiates the communications, sending several things in, the server receives and sends several pieces out. And how do you write this? Just by adding the stream keyword between the inputs and the stream keywords towards the output type. Okay, so let's see how these are displayed in some demos. Okay, I have here a few projects. I'm gonna wrap them, and I hope the screen is good enough. So first of all, if you want to create a new project, gRPC project, you simply go ahead, open new file, and you'll see there in templates, gRPC. And it's simply a project template for creating gRPC services. And if we click next, we'll be requested to send, to provide names and so on. .NET 7 is what I use here as the preview version. Fingers crossed for my Visual Studio not to crash. Okay, so let's look a bit at the structure. You all coded at least once something in relation to MVC or Web API. And you'll see that in here, we have no more controllers folder. So we have no controllers. We have program CS where everything is bundled. Okay, you have here the middleware that says this is using gRPC, and it's mapping a gRPC service called greeter service. Okay, this will be on the root of the project. And then we have to look at the proto file. The proto file is something that is included in the template, but you might as well go ahead and create one yourself. It has the things that I showed you, okay, the syntax for it, the namespace that will be generated for you, the package, and then the service definition. If we were to think a bit, if you ever work with SOAP and you've seen a whistle page, this is pretty much, it resembles a bit, right? But it has operations. Okay, this proto file is the thing that basically says, okay, this is what I'm exposing, this is I'm gonna get in, this is what I'm getting out from the system. Okay, app settings JSON is, we all know it, and the greeter service I'm gonna show you is basically an implementation. This is where you give an implementation for everything that is specified in the definition. Here you specified it, just like an interface. And in here in the greeter service, you override those and just giving an actual functionality. You'll see here that the greeter service that comes with the template is just a class that inherits something. And that something is basically generated. As I mentioned, gRPC does code generation for you. And if you open that file, you'll see some funky code. Okay, but that funky code basically allows you to override and create a base class for you. And I'm also going to show you what does some things extra. Okay, I'm going to close this and getting, oh, no. Why Visual Studio? Why? It closed itself entirely. But I'm going to open the project and I'm going to show you either way. I implemented basically the four methods, so I'll be able to show you how everything works. And after that, I'm going to show you some things that were introduced in ASP.NET 6 and 7 regarding server transcoding and client-side load balancing. Okay, getting back, the server looks like that. The proto file that has four methods. Okay, say hello is the thing that comes with template, server stream, client stream, and bidirectional. And instead, to make it a bit more resemblant to request response that we all know from HTTP, I named the message request and has a field name called that value, and the response name response with, again, a message. Okay, so getting to the client greeter service, we will look at each and every single one in particular. First of all, at say hello. First, how do you make a thing to be a gRPC server? By just editing it will be done by the template, but if you ever want to make a thing to behave like a server, you will need to include this. So you will need to include an item group with the property gRPC services called server. And also you will need to point where the proto file lives. In my case, the proto file lives in the same solution, in the same project, but well, you might as well open and put it at some level upper or in a different location on the disk and so on. And you simply could point to that proto file and make sure that your project has access to that specific file. Okay, having this server, I'm going to run an instance and I'm going to start it. I have here several, where is it? Server, .NET run. I'm going to .NET run it. And you'll see that the project is building. And it listens on port 5000 and on HTTP on 5001. And then I'm going to open a console app. A console app simply with what we all know a console app is. You just need to add a few things like gRPC package and gRPC ASP.NET Core or gRPC Net Client. These are two ways of using gRPC. What is provided in this package or this one. But of course, similar to what we had in the server part, we need to specify that this particular project is a gRPC client. And you're doing this by specifying the value in here. And then you need to point the proto file that is accessible. So you'll be able to make sure that the client has access to it. Okay, so what it points to the proto file that is in the previous server folder. Okay, so if we were to look at the dependencies in this specific project and at the packages, you'll see our console app has absolutely no knowledge of the server. So We didn't right click, add package, scroll to the project and so on, and simply just added that. Okay, so no code reference. The only thing that these two projects have in common is the proto file. Okay, so let's see how the unary thing is running. So left-hand side, you're seeing the server running, waiting for incoming requests. And on the right-hand side, you're gonna see a client running. And this client will make a request to the server, and we'll see how the requests are incoming, okay? So what it does, hello world is sending a hello Joberty webinar, and it gets back a response with hello back with the property that we send in request from localhost 5000. So simply request response. And one thing that is worth noting is that on the server side, we are not seeing HTTP requests. We're seeing HTTP 2 requests. These are not GET, these are POST type requests. And they are of type application gRPC. So no more JSON or things like that. We're talking gRPC right now. Okay, so on the client side, let's look a bit at the code. On the client side, how do? We create a client in the same way we would create a client for HTTP clients when we would do HTTP calls towards other APIs. By the way, this thing called gRTL client, it's not written by me, it's generated by gRPC in that specific funky code that I showed you before. So it allows us and creates for us a client. But what you need to do in order for this to work is to create a concept or a concept that is called a channel. gRPC works with channels that have URLs or addresses specified and options. And with those options, you can pass in credentials regarding security. In my examples, I have everything unsecured because it's not the focus for this. But you can add SSL, you can add certificates and everything. You can extract claims and whatever you need in here. Okay, so once you create the client, you also need to create a request and for the specific request to populate it with a specific value. So I sent here, hello Joberty webinar, and in our responses, we get, see, we sent hello and we get back this from a specific port. Okay, and what do we get back? We get the response by calling the specific method. So we're not calling an URL, we're calling methods. We're not calling HTTP as we used to, it's just calling methods and passing parameters to those methods. And we extract from the response the fields that we have the message fields and so on. With the response, when we call the response, we can also add things like this. We can say, hey, if a response doesn't come back in 5 seconds, kill it. You can add deadlines. For example, send the request, call it a deadline, and also you can pass cancellation token. So for example, you can add milliseconds, or you can add, this is a date time and so on. You can add milliseconds and this will be killed right from the start. But if you want to have to specifically add something for that request, you can add it in here. Okay, so you can add several options. Let's see how anything else works. We had the unary one. So because we had the unary one, we're gonna close it. And you're gonna pass to client streaming. I'm gonna move this and .NET run it. You see on left-hand side, request awaiting, and you'll see things are moving. Okay, client side, as I told you, assumes that a lot of things are streaming in. So the client sends a thing, several things, and it gets back one result. So look on the server side what happened. Okay, the server writes back that it got a request with a content value with an I that is in a loop and it's increased in here. Okay, so this you see several pieces of data. But if we look at the info in here, again, we called an HTTP2 post request to that greeter client stream of type application gRPC. And several things in, one thing out. And 1999 is the last value the server received. So the last value of the I. And by looking at the code, client streaming, I said. Okay, again, we created a channel for localhost 5000, insecure, we created a client, and from that client, we called the method named client stream, okay? So with an I going from 0 to 10,000, we simply wrote requests, and those requests reached the server. And on the other hand, the server awaited our requests and just written back the messages. Okay. One thing that I want to note here is regarding status codes. If we all know status codes for 104, 200, okay, and so on. When we're talking about gRPC status codes, these are not applicable anymore. gRPC will have different status codes specific to gRPC, and you can access them just by catching exception and filtering out the exception type. Okay, for example, if something is thrown, like an RPC exception being the only type of exception that you can catch regarding or related to RPC, you can see status code. And this status code is, for example, aborted, not found, already unavailable, data lost, failed precondition, out of range, permission denied, and so on. Okay, but these are not in any way similar to what we know as status codes from HTTP. Okay, moving on, the server is still waiting for requests, and we will do the server streaming one. Right-hand side, again, .NET run it. This time, the server should send things into the client. Okay, you see, the server sent things. The same scenario with I increasing in a loop. But you see, in the server side, it's nothing. It's one request incoming and several pieces of data sent out. This is very useful for example, I don't know, notification scenarios for specific client, or, hey, I'm watching a thing, I'm watching a queue, a thing came in, here's the thing, and so on. Okay, so one request, several things from the response, as we see here. Another thing that we will mention soon is regarding the headers that you can send with the request. But then let's look also at the bidirectional one. And again, left-hand side, the server waiting, right-hand side, the client running. Okay, what happened is an I going from 0 to 10 was sent to the server, and also it was received back from the server. But don't get confused, the order is not guaranteed. So if you, this is what happened in this particular case, but maybe the message that came back might be scrambled in your case, in your specific scenario. So bidirectional. One thing that I want to note here is that bidirectionality, it happens inside one TCP connection. So there aren't several. It's like one channel open, and inside that channel, a lot of data travel back and forth, which is very, very interesting, if you ask me. Okay, we covered all the four scenarios, but also we need to look at a few gRPC concepts that are internal to gRPC. One of them we already covered, like status codes, is different than HTTP status codes. RPC exception, request headers and response headers is a thing that I want to emphasize, and response trailer. In response headers and response trailers, we will see a thing like, in here, we saw a thing, where are you? Server streaming. A thing like this, function trailer values called gRPC header. Because for server streaming or client streaming, you're sending several pieces of data. Those pieces of data have no way of sending actual HTTP headers because are inside the TCP connection. And you can mimic those just by simply adding, I think that is called entry metadata header, and adding in a context name response trailers. It's simply a dictionary key value that you can add to that specific gRPC request or response. It's up to you. And you can access the specific request or what happens with the gRPC request or response by accessing the context. Just simply going there and say, hey, it's like in HTTP, get HTTP context that you all know from MVC or web forms or web API. You access the context, and from that specific context, you can access data from claims principal, certificates, test things, access the request header that is specific to gRPC, or simply add a thing in there, just to mimic how a gRPC, how a normal request would look like. Okay. One thing that I also need to note is that every method that you will implement, no matter the way, whether unary, client streaming, or server streaming, will have a third or a fourth parameter called server call context. And that is the specific gRPC context for that specific call. And that is what it allows you to extract some additional things like HTTP context, the headers that you attaching and so on. Okay, so server context is there and it's implemented, and you will need to carry that with you every time you implement a gRPC operation. Okay, so response trailer is how you work with things. Another thing that you can tweak in gRPC is, for example, to say what is the maximum received message size, and you can act upon it. You can say, hey, if the request size for that specific request is bigger than this, you can cancel it or throw an RPC exception. Also, you can compress things. As we all know, it's a good thing to compress responses when you're talking to outward facing APIs. And you can specify the response compression algorithm if you want. You have a list of compression provider that you can add there, whether broadly or your own. It's up to you to implement this. And of course, we need to talk about security, how security works in gRPC, even if we won't cover it in here. Well, everything that you know in terms of authentication, it's supported. But it's supported at several layers, at the channel level and also at the connection level. So you can also support Azure Active Directory, client certificate, JVT. Oh, why I added JVT token? Because JVT already has a token. Auth, OpenID, WS Federation, and so on. You can see in there a lot of scenarios. It's implemented and it's possible. So let's see some other things. Benefits. Why would someone use gRPC? Well, for the performance versus size benefit. In one example, gRPC would be like 80% smaller than simply HTTP, so-called REST API. So you can benefit from this. You can have polyglot environments. It will get you low network usage. Think about if you have a small payload and you have little data to transfer over the wire, then it's low network usage. And it's perfect for point-to-point communication if you know that you have service A to service B, and those are internal to your system, and you need to make them talk to each other. It's very important. It's very, very useful. But also it does several calls over the same TCP network. It uses the HTTP2 multiplexing. So we have one channel and several things traveling back and forth. It's contract-based. It has smaller payload, faster. You cannot beat that. And it supports different streaming types over single connection. So performance is paramount. Also, in .NET 6, it can also be configured to run with HTTP 3. I don't know about you guys and girls, but HTTP 2, just starting to get my hands on that and so on. And now they're talking about HTTP 3. I simply cannot keep up with it. There are a lot of differences and a lot of things to keep in mind. Okay, so this is a short summary like that, but in fact, since .NET 6, because we're talking about .NET 7 launch in November, what gRPC supposedly does awesome? Well, gRPC supposedly does transient fault handling out of the box. So gRPC has a thing that is called, it has policy. Have you ever used poly? Because poly is one thing that does transient fault handling. I'm going to show you just a sec. Okay. Here. I'm going to show you, I'm not going to run it. But for every call that you will doing with a gRPC client channels, you can specify things like, hey, give it a name to that specific policy, but you also can specify a retry policy. For example, you can say that maximum attempts is 2, and then you can also specify the initial backoff, specify a time span from it, maximum backoff, and so on. Multiplier for it, and of course the retriable status codes. For example, when do you need to retry something? When, for example, the gRPC service that supposedly will give me back a response is unavailable, or when a thing is deadline exceeded. So you can configure a lot of either retry policies or either hedging policies, with hedging delays or maximum attempts on non-fatal status codes. Well, now these are topics for a different talk entirely, but you either can configure a retry policy or a hedging policy, and you add this method config, and further along that method config, you pass it in the gRPC channel option. This gRPC channel option is very potent, if I can say like this. It has a lot of things that you can configure in there, policy providers and so on. It really deserves a dig deeper inside it. Okay, let's see what are the things should gRPC do very well. Client-side load balancing, ain't that cool? We all know that, well, client-side, not client-side, load balancing, it's an important topic when it comes to reliable systems. Or you do not want your system to not respond when it's bigger load, right? And what do? You simply spin off another instance, okay? And how do you handle the load balancing of those instances? How do you decide that, well, when a request comes based on a specific algorithm, the request should be routed to the first server, and when the second request comes, it should be routed to the next one. So how do you decide this? Well, there are policies to do to configure. With gRPC, you have two ways. You have DNS resolver factory that you configure, and a static resolver factory. And as policy, you have two out of the box. You have pick first, like pick the first one that's available or that comes into the rotation, or round robin. Or of course, if you want, nobody will stop you to implement your own resolvers. I don't know, maybe take 3 requests here and the 5th one in there and so on. Yeah, sky is the limit. But let's see it in action. So what I'll do, I'll leave my server instance running, and I'm gonna spin off another server instance. This is server number 2. This listens on port 5002. So 2 instances, 5000 and 5002. I'm gonna leave these Oh my God. Hey, screen, move it back. Okay. Now it's here. This can be closed. Server. So 2 server instances running. Where are you? Left-hand side. On the right-hand side, I have a project named extra gRPC. I'm going to clear this because I want to show you some code before. So what I do here is to say, hey, I have to configure some client-side load balancing. So I know that I have localhost running on this port, and I also have a localhost instance running on this port. So 2 instances. So if I know this by heart, I can add them in there, or of course, it's up to you. I just hard coded those. You can implement an automating system, and I also advise you to do that. And then you can configure the service collection. You can add the resolvable factory as a singleton. These are details. But what we care now is that for a channel that will do gRPC requests for us, we're going to specify a name for the policy, and we're going to say, hey, I have these options specified for this specific channel. Of course, we do not care about security right now, but we need to say, hey, I have a service configuration, and for the load balancing configuration, I want you to use the round robin config one. So round robin, the first and the next, the first and the next, because we only have 2. Okay, we're gonna wrap everything out, and then we're gonna do the actual call. We're gonna instantiate the request. So this is the request message that we had in the proto file. I'm gonna give it a value, and then I'm gonna create a client. And finally, we're gonna pass the client the request in the client and call say hello method. Let's see, extra gRPC. Okay, 3 instances running. I have this. I'm gonna .NET run it. I should have pressed no build, but it works like that. What it does, it says hello back with the Joberty value from this server. And if I run it back, fingers crossed, it should, fingers crossed, I said. No. My demo does that every single time. Let's see, extra gRPC. Let's see what's running. We are running, this is running 5,000. I'm gonna stop this and make sure. Okay, this one. Whew. Round robin, but well, as you see, we get responses from this server and from this server. And this thing is particularly helpful if you have Kubernetes pods that you want to spin off, right? Another one and another one, and you can load balance. Okay, so simply just by passing here round robin config, and also you can specify pick first config, or you can add your own config in there if you ever need that. Another thing that you can configure is to have a DNS resolver factory with the refresh interval. I'm not going to run this because I didn't test it very well. But if you know the DNSs and you have everything configured, you can also add this as a resolver factory and pass this along similar as you would do here. So balancing by itself. Now, another thing that I don't think I added on my slides is that a lot of people are running from gRPC saying that, hey, I also need to expose my API to the outside world. I need to have an API, a RESTful API that is callable from consumers and consumed. And if I use gRPC, I cannot expose that to the outside world. And now we can. So you also can have your gRPC servers consumed internally and expose that as a RESTful API. How you do that? Well, by using gRPC transcoding. gRPC transcoding is available in .NET 7. It's a bit of hack right now, but I'm sure that they will fix these things until they release the final version. So how you do, it's a bit of a trick to implementing here, but it's a simple gRPC service from the template and so on. You see, add gRPC. You need to add a middleware named JSON transcoding that comes from a package that is in the package named gRPC transcoding. As you see, this is for the preview version. You just add in it here, nothing else is that you do. And another thing that you need to add at this moment is to have a specific thing, like having a folder named Google, and inside the Google folder having an API folder. That inside has 2 proto files called annotation and HTTP proto. These are, you can copy this from GitHub, from James Newton King for the moment. But in your proto file, you will simply need to add the import, just like you import a namespace using, you have the similar way of importing another proto files if you want to organize your code very well. Okay, so from Google API annotation.proto, you need that. By adding this, you'll be allowed to do something like that, saying, hey, I have an RPC method that has a hello request in and returns a hello reply, but I also need to have the option of exposing this as simply HTTP API to the outside world. I need to be able to use my my specific gRPC service as a GET in the browser by passing this path, v1 greeter, and passing in a name. Let's see how this works. I'm gonna debug and start new instance. Hopefully things will work. Okay, listen to this port. I'm gonna go with this HTTPS. I'm gonna open the browser, paste the code, and I said, hey, I need to have greeter, and the name parameter is Joberty for today. Joberty. Hey, and I get back a message named hello Joberty. But this might not be surprising. It's a JSON, right? It's a JSON, it's a message property that has this value. And if we look at my code, we have no controller that is exposed here. We have only these options to call a specific operation, expose it as a GET. You can also expose it as a post if you want, and also send a body. You can specify what kind of body you can have in here, just by adding this import with those files. And in the services, look what I have. It's a simple implementation, getting a response, and writing in the console the message. That's it. Okay, so if you do not believe me, let's see what happened. You see, you just have a GET request to that specific URL. You get a 200, and you have an application JSON as a response, right? But also, we can call the same service from Postman. I had a script at a certain moment in my presentation because Postman didn't support gRPC, but now it does, and it does it very well. I have a collection in gRPC transcoding. I have this, the port. I haven't yet managed to make it run on HTTPS from Postman. It's still in beta, so I don't think it's from them, maybe from me. But as I said, with gRPC, you're creating only posts requests, so this will be a post. And in Postman, you have the option of generating an example message, or just adding in here, I don't know, Joberty from Postman. Okay, this is a message. I have a say hello in my greeter service on my local host transcoding API. And if I invoke this, Service unavailable. What could happen with live demo? Service unavailable, right? Why? HTTP localhost, HTTP localhost. Anyways, until this is fixed, let me show you something. How to use Postman. You can do this. New, you can go to gRPC request. And in the gRPC request, you can import the proto file. And you can choose the file, just go wherever your proto file lives in. You will import that. And as a result, you can add the path. Make sure you don't have trailing slashes or HTTPS in front of it because it won't work. But what that will do is extract from the proto file the methods that you are exposing. So I have in the first API, the server that we use for the demos, we had say hello, server stream, client stream, and bidirectional. And if you select one of it, to make sure the message will be populated and you can invoke this. What happens? Say hello. URL have TLS enabled if required. No connection. Why? I'm gonna run it again, but I don't see it as being an issue because I tested this before the presentation. Invoke this. Okay, you need to take me by my word for this if it's unavailable. Is returned the service currently unavailable. Okay, makes all the sense in the world. This lives here. Server 2, I'm going to close it. Yes, but if that is running, why? Okay. Giving that a go, we're going to move on because this doesn't want to cooperate. Transcoding API, let's try this again. Debug, start new instance, and make sure it works. It stopped. It stopped. And that also. Fingers crossed. Transcoding API, invoke. This responds, so which is, I don't quite understand this. And this one again. This is a way of metadata empty. Why metadata is empty? It doesn't want. Anyways, moving on. You'll have the resources and you'll be able to run them by yourself. I have a link at the end. Okay, so besides demo might not working during the live presentation, there are a few downsides of gRPC as any other technology. You will have temporal coupling. So if you want something that won't have this kind of coupling, you would should steer yourself towards messaging, like service buses and so on. You might forget that there is a network involved because you simply call a method. It's very developer friendly. It's not human readable until now, because until now, Postman didn't work and you would simply send binary code. And as far as I know, I personally don't know how to read binary, like reading text. You'll need better testing and you'll need to focus on CI/CD because that specific proto file is the thing that travels back and forth. And you will need to make sure that your system have access to that specific proto file that supposedly is the common ground between your services. It does only HTTP post, even though we have gRPC transcoding and you've seen that behaving as a HTTP GET request, but that GET request is specifically made by a reverse proxy inside the process in ASP. I have an article written for Joberty regarding that. But having post, you use caching, and we often use caching to speed up or to speed up or to increase the perceived performance actually. And there is a single point of truth between any two systems, the protofile. And another thing, not supported in Azure yet, and I should have crossed this because yay, after 2 years, they support now gRPC in app services in Azure. It stayed as not supported for about 2 or 3 years, and in May, I think they released and announced that is in general availability right now. So this is not applicable anymore. So gRPC versus REST. gRPC, you'll see many comparisons between gRPC and WCF, and it's normal to see that, but I add this as comparison with REST because I think it's meant to replace REST, because if you have systems that are running on WCF, you have some other problems. But in comparison, REST or HTTP APIs are RESTers focused, are focused more to the outside. They embrace HTTP semantics and hopefully provide loose coupling if they're implemented properly. They're text-based, and RPC is more developer-friendly. It's action-based, do that, call that method, get that input, get that result back, and embraces more the programming semantics. And you have tighter coupling, even though you have simply one file and that travels around the proto file and you have no more code references. And it's binary. And if you know how to read binary using Postman now, it's usable. But when and why the gRPC, and why I advise you to try and use at least a gRPC. It's great for microservices, for downstream communication, for point-to-point, and it replaces gracefully HTTP clients. And it adds that extra benefits from the 4 modes on one TCP connection. It decouples code. You won't have anymore the packages that have HTTP clients that travel between your APIs that tend to get some more business logic than they should be. So we all know that the distributed systems are about trade-offs, and these trade-offs can be measured by knowing the tools. And gRPC is just another tool that can solve a lot of business problems or can replace some HTTP calls if you have microservices, or you tend to have microservices. So as next steps, I would advise you to just have a quick look at gRPC Web, because gRPC Web is that part that allows browsers to call gRPC server, and it's a different implementation altogether. So this thing is the part that a lot of developers were having against gRPC. Hey, but I cannot call that from a browser. I want to reuse my code. So if I'm using an API to API calls for downstream communication, I might as well expose the same API for a consumer over HTTP in browser for a front-end client to consume. And you couldn't do that, but with gRPC transcoding now you can. It uses HTTP2, so have a look at HTTP2 and try to use it as much as you can just to keep up with what happens. HTTP3 as spec, proto syntax from Google, gRPC curl, if you love to curl and make requests like that. Postman in beta, and also Bloom RPC. If you have ever used Java, that is very known in the Java world. It's very similar to Postman. You just load the server, and if this opens, something happened apparently with my, see, you just load the path, you specify which is the proto file, where is the proto file. That proto file will open this as a service, and this, you see, this annotated as methods, and it's simply, and it also shows you that this is a unary, this is server streaming, client streaming, and so on. So it's easier for you to work with. But if you do unary call, you hit play, what it says, 400, bad request. Okay, awesome. It's not for web. I want to do gRPC. Yay, now it works. But from Postman, why it didn't? Anyways, so server running, hello back. Let's see some others, because if this works, it might work. Hello, client stream. You see server is streaming, so it's still running. So I'm getting things back if the things are not breaking. Or it will break. Bloom RPC, apparently it's more stable than Postman because on the same scenario, this responds.
Hi, Irina. Sorry for interrupting you, but we need to leave some time for Q&A session.
Yeah,
so
yeah.
Just have in your mind, I don't want to rush.
No, I was just about to finish.
Okay, okay.
You have this bit.ly link. This bit.ly link. You can get resources from there, including the presentation, the source code, and so on, or by using the QR code. So sorry, I was used with 60-minute presentations.
No, it was great. Yeah. Thank you.
I'm sorry for being late.
Do you have anything else to share with us before we start today's session?
Yeah, if you find yourself in Iași or you're willing to travel, we'll be waiting for you at .NET Days in 2020 October this year in Iași, Romania. So I hope to see you there. I'll for sure be there.
We'll look
Thank
forward to it. This sounded and looked really impressive, but to be honest, I didn't understand much because I'm from marketing. So, but I see reactions and I see that people are writing us in chat that they really like the webinar. Nobody didn't leave the webinar until, I don't know, maybe 10 minutes ago. So this is really impressive and thank you. It was really great. So we have some questions in chat, and also I would love to encourage everyone else to write their questions if you have any. So maybe it will be the best if you read the questions, because I'm
exactly
I will pronounce it well.
I'm gonna scroll this. Also, feel free to contact me on Twitter and to connect on Twitter. I respond to messages and so on. Okay, so let's see for the question. Is the gRPC call synchronous, or it does support the sync code execution? I mean, in .NET specifically. So gRPC calls are async. By default, if you write the code for it as it can be sync or async, depending on how you're implementing the specific operation in the services. So for a specific thing, I'm going to show you short like this. You see, I'm returning tasks, and I'm awaiting things, async task, and so on. So I wrote the code to be asynchronous. Okay, Adrian Oltan asks, can you host a gRPC server on premise in IIS Windows Server 2016? In IIS Windows Server 16, you need, I think, a newer version than 2016 to host the gRPC, because it needs to allow gRPC HTTP2. But yes, gRPC was hostable before Azure App Service. You can basically, the .NET app is a console app. You can host that on Windows, then you can also respond to gRPC. That's it. What do I mean by saying gRPC is 80% smaller than HTTP? Taking a response from an HTTP API and the same response for the same scenario from a gRPC service, the response is 80% smaller in gRPC than in HTTP. Thank you for that. I will also clarify it in my slides for the next presentation. Let's see. Another question. Question. Thank you for the thumbs up, guys. If you have any other questions, I'm not seeing any.
Yeah, I think that's it. But feel free to contact Irina, as she said, on LinkedIn or Twitter, or feel free to send us some questions, and we will share it with Irina.
The books, Anthony Giretti wrote about beginning gRPC with ASP.NET Core 6. It's a great book to look for specific services. And gRPC for WCF, that is free. Google it. It's from Microsoft. Mark Randall and Miranda Steiner wrote this, but it has a comparison with WCF, and it works more towards WCF comparison. So the two books that are great for this.
Also, we have a question about recording. Yes, we will share the recording with you right after the webinar. And Milos Lazovic raised the hand, I think 20 minutes ago. But Milos, if you want to ask something, feel free to write us in chat. Or maybe that wasn't on purpose.
Or DM me on Twitter.
Yeah. So, Irina, thank you again. I hope that we will have another opportunity to talk on some other subject. I hope everything was okay from our side, and I see that the crew is really satisfied with your presentation, and we will share it, as I said, right after the webinar. So do you have something to add, or maybe, I don't know.
Thank you for having me. Thank you for having me. And I really enjoyed this, and keep in touch. Until next time.
Great, thank you. I would love to invite everyone once more to register on your local Joberty platform, to share your experience, and to help other IT professionals in their career decision, and to help us to build better IT world. Once more, we would like to remind you that you can join our giveaway. Follow us on social media, because we will announce the winner tomorrow through our Instagram and also through email. That will be it for today. Stay up to date with our channels and stay up to date with new events, and see you soon. I wish you a great day. Bye-bye.
Bye.